For our final video on solving quadratics by square roots, I wanted to start by showing you a sample problem of when we would recognize to use square roots and when we might need to use something else. If you notice here, between the two problems that I have listed, one of them's a trinomial and one of them's a binomial. And this trinomial has this bx term, this middle term. Whenever you see a trinomial like this, you should immediately know that square roots is not going to work. And let me show you why. If I were to take this and subtract the 4x and the 4 from both sides, and then eventually take the square root of both sides, I would end up with an x variable in the radical. And because of this, we're simply not going to be able to solve for the x unless we undid that radical, which would basically bring us back to where we started. So you can see that this method of having a bx value is not going to allow us to use square roots. Now, hopefully you recognize that x squared plus 4x plus 4 is a perfect square trinomial, and we could solve that by factoring. Now let's take a look at another scenario. Here, hopefully you recognize x squared plus 4 as a binomial. Doesn't have a middle term, but you also need to be very aware that this cannot be factored. Okay, x squared and 4 are both perfect squares, but since we have an addition sign, it cannot be factored, and so we would want to use square roots here. And so then we end up with this situation right here. Plus or minus the square root of negative 4. And of course, if you were to punch this into your calculator, you would get an error. And it would basically say that there is no real number that when multiplied times itself is going to give you a negative value. And so we need a mathematical way to deal with the square root of a negative number. And so that's where we come to the next part in our notes. What mathematicians have basically come up with is a system called imaginary numbers, where we can have a variable that is going to equal to negative 1. So we're going to use I to represent what we call the imaginary unit, or sometimes you see people call it the imaginary number. And when this I squared equals to negative 1, I can equal to the square root of negative 1. And so this is going to be vital in helping us simplify problems like we just saw. And so now what we were able to do is we're going to be able to actually simplify the square root of negative 4 and multiply it times the square root of negative 1, and that allows us to detach the negative, and that'll give me plus or minus 2, and then the square root of negative 1 is just going to simply be I. Now, this is important from the standpoint that we can now have a way of solving these quadratics where we end up getting a negative value under a radical, which will happen fairly often. So now, a couple things about the imaginary unit, about I. Even though I has a very specific value of the square root of negative 1, it acts in many cases exactly like a variable does, just as if it were an x or a y. So we can combine like terms with it, we can multiply it, add, subtract, things of that nature. So it's really nothing different than what you may have seen in the past with variables, just the fact that it has a very specific value. So let's see how it can help us out in solving a question where we need to solve the quadratic. So an example, in this particular example, 3x squared plus 10 equals negative 26, we simply want to do like we've always done. Isolate that x squared term. And then when we isolate that x squared term, we want to take the square root of both sides. Now, in this particular case, we have the square root of a negative number, so we need to get that negative value out of there, that square root of negative 1, which is an I. And then we can simplify the square root of 12. Now, let's be very clear here. The order in which you should write this would be the coefficient first, then the imaginary unit, then the radical. So that ordering of 2, then I, then square root of 3 is very important. And we want to do the radical last, and of course the I acts like a variable, so the coefficient should come in front of that. So get comfortable writing your final answer in the correct ordering of those right there. So we have a sample problem here, part A and part B. So go ahead and take a moment to work those two problems. Alright, for part A, we simply just want to isolate the given x squared term. And so when we do that, we're going to get negative 36, and then that's x squared equals to a negative 18. X is going to equal to plus or minus the square root of negative 18, and then I need to break that apart. And so you can see I can break that into the square root of negative 1, square root of 9, square root of 2, and then I can write the whole thing out as 3i square root of 2. Again, it solves my quadratic because it gives me both the plus and the minus roots, and so that is the final answer. And then we'll do one more. So 5x squared equals negative 10, x squared equals negative 2, x equals plus or minus the square root of negative 2, and this is simply plus or minus I square root of 2. And that is our final answer. So now we can see we've introduced the imaginary unit as a way to help us deal with the square root of a negative number, and this will help us continue to solve quadratic equations with square roots.